In a survey of 520 TV viewers, one study found that 340 were regular watchers of a popular TV series. Assuming that this sample is representative of the population of TV viewers, find the 95% confidence interval of population proportion of TV viewers who watch this particular TV series. Part B, 99% confidence interval of population proportion. And part C, which confidence interval is wider and why. So we have to read the problem first line again. In a survey of 520 TV viewers, so 520 is a large number, is the sample size, out of which 340 were regular watchers of a popular TV series. So if watching that TV series is considered as success in this problem, then the sample proportion of success, P hat. So we will solve this problem. The sample proportion of success is given as P hat, to be read as P hat. P hat is X over N, is number of successes over sample size. So in this case, out of 520, 340 were watching that particular TV series. Watching that series is success, as I said. So it's a small number divided by large number is equal to 340 divided by 520, and that is equal to 0.654, you might say, rounded to 3 places of decimal. Now we have to construct a 95% confidence interval for P. Confidence interval for P. Is the population proportion of TV viewers who watch that particular TV series. Here we will be using TI-84 calculator. So use TI-84 calculator. Okay. Because that will be faster. So first we will press the stat button. So stat button, which is in the second row, then highlight means move the cursor on the top row to test, and then scroll down. Remember, this is a proportion problem, so we are scrolling down to 1 prop Z interval. So we scroll down to A as in apple with the down arrow key to 1 prop Z interval. It is a short of 1 proportion Z interval, and hit enter. Okay. So next it asks for our X, which is the small number, which we just now did is 340. N is the sample size, which is the large number. N is 520. And the C level is 0.95. Usually the calculator is set as 0.95. If it is not so, change it or type 0.95 after the sea level. Then we go down to calculate, put the cursor on calculate and hit enter twice. Enter twice. No, enter only once. I'm sorry about that. So we got to erase this. Enter. Twice is only when you are on paste. So enter. Okay. So let's see what we get numbers. So we get two numbers, the lower boundary and the upper boundary of the 95% confidence interval, which is 0.6193 to 0.695. What does it mean? With 95% confidence, this confidence is in the effectiveness of the method that we use to construct that interval. With 95% confidence, we can state that the actual population proportion will fall between 0.613 and 0.695. Okay, so that is your answer for part A. Okay, so part A is this. Part B, 99% confidence interval. 99% confidence interval. So we will repeat the same process. Notice here the width is the upper boundary minus the lower boundary, and that is equal to 0.695 minus 0.613. 0.695 minus 0.613, and that is equal to 0.082. This is a point to be noted. This information will be used later. So now, right now we are ready to calculate the 99% confidence interval. Let me change the color of my ink to something else. So again we will go stat, then highlight test on the top row, then we'll scroll down with the down arrow key to A, which is 1 prop Z interval. Okay, and for X we will not change anything. X will still be 340. N will be 520. Only thing we will change is the sea level. Here it is 99% confidence. So we will type 0.99. Then we go down on calculate. Bring the cursor on top of calculate and hit enter once only. Enter. So stat, highlight test on the top row. Scroll down to 1 prop Z int, which is 1 proportion Z interval, and hit enter. X is 340, N is 520. Only thing we will change is sea level to 0.99 and we will calculate. Okay, now the confidence interval is 0.600 to 0.708. So now notice the width of the interval is equal to 0.708 minus 0.600. Okay, and that is equal to minus 0.600. and that is equal to 0.108. This is a point to be noted. So looks like the part C, width of 99% confidence interval is 0.108 and width of 95% confidence interval is 0.082. Therefore, width of 99% confidence interval, let me write it as CI. CI stands for confidence interval. Is greater than width of 99% than width of 95% confidence interval. Question is why? Because width of an interval, width of a confidence interval is equal to 2 times margin of error. So, margin of error is given by critical value times standard error. Critical value, let me erase this. Okay. Critical value for 95% is equal to 1.96 and critical value for 99% is equal to, let me make sure I'm writing the correct thing. How do I get it? So area in the center is 0.99. So area in the two tails is 1 minus 0.99, which is 0.01. That is area in two tails. So you have to divide 0.01 by 2 to get area in each tail. So area in the left tail is 0.01 by 2, which is 0.005. So if I do second verse 3 in norm, put the area as 0.005 and go down to paste and hit enter twice, and critical value is 2.576. That is the main difference between the two margin of error. Okay. Also, what is standard error? Standard error is equal to standard deviation of the sampling distribution and that is equal to standard error is equal to square root of p hat times 1 minus p hat over n. So in our case, remember we determined the p hat initially, which was 0.654. So we will do second button and x square. Get the square root. Inside the square root, we first type 0.654, then left parenthesis 1 minus 0.654 divided by n is 520. So again, standard error Let me change the color of the ink. Standard error is equal to second x square, second button, then x square button gets the square root. Inside the square root, type the p hat value 0.654 times 1 minus 0.654. Close the right parenthesis, then divided by n is 520. So standard error becomes equal to standard error is equal to second x square, which is square root. Inside the square root, first the p hat value, which is 0.654, then left parenthesis 1 minus 0.654, right parenthesis, then divided by sample size 520. And the answer is 0.0209. Hence, margin of error for 95% of error for 95% confidence interval is critical value times standard error, which is equal to critical value is 1.96 multiplied by 0.0209. So 1.96 times 0.209, 0.0209. So they have a mistake, so I have to correct it. 0.0209. So 1.96 times 0.0209, and that is equal to 0.0409. Hence, width of interval for 95% confidence interval is equal to 0.0409, which is margin of error times 2, is equal to 0.082, same as what we got before. If you look over here, margin of error for 95% is 0.082. Okay, so, okay, let's change the color and do the margin of error. Margin of error for 99% confidence interval is equal to critical value times standard error. That standard error is remaining constant between two confidence intervals. Okay, it does not change. Only the critical value will change. Here it is 2.575 times standard error is 0.0209. So that is equal to 2.575 is the critical value times margin of error times standard error is 0.0209, which is 0.0538. Hence, width of the 99% confidence interval is equal to 2 times margin of error, which is 0.0538, which is equal to 0.108. Okay, This is equal to what we have obtained before. If you look at uh, 0.10, bottom line confidence interval, or let me erase this. Width of 99% CI is greater than width of 95% CI. That is the final conclusion. Okay, I stop here today. If you have any question or comment, write me a note. If you like this video, please give me a thumbs up. That really motivates me to work hard to produce some more new videos. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And also please click on the bell button, because that will notify you every time I upload a new video. So please do not forget to watch me tomorrow when I'll be back with another interesting video. Take care. Have a nice day. See you.